Lesson 80, finding the normal distribution. Now, the word normal in statistics doesn't mean what you think the word normal means. They just call it normal. If it's not a normal distribution, they call it what do you call it? There's going to be like binomial distributions. There's normal and binomial. There's no such thing as an abnormal distribution. So it's not the same definition that you would think the word normal means. Sometimes in math we have different. So a normal distribution looks like this-ish. There we go. This is the bell curve. This is called a bell curve, and it has a normal distribution. The bell curve is where the mean, the median, and the mode are all equal. It's okay. Okay, so
How do you find the equation for a bell curve?
when you have a bell curve, I'm doing the best I can. Oh, that's pretty good. Okay, so right here is the mean. We call that mu. Sometimes, how come I put a mu there? Because that's the mean. Okay. If you were to, these are called standard deviations, and that's just the distance away from the mean. Okay, so it's not always 10, 20, 30, but I have 10, 20, 30 on mine. I'm not gonna do anything here. So right here, between these two, so one standard deviation away from the mean, above and below. 68% of the data will fall between those two numbers. So then if you do two standard deviations above and below, you have 95% of all the data falls between those two standard deviations. And then the last one, 3 standard deviations, you have 99.7% of all the data fall between there. So this is called the 68, 95, 99.7 rule. Random numbers.
Rolls
Yeah.
off the tongue.
Kind of just rolls right off the tongue. So the sign determines whether it's above or below the mean. So if I had a positive 10, I would know it's above the mean. If I had a negative 10, I would know it's below the mean. So I just want to give you a bunch of examples of how we use this information to help you out. Since 68% is one standard deviation below to one standard deviation above, you can divide that in half and get 34% will be between these two lines, the mean and one standard deviation above. And 34% would be between the mean and one standard deviation below. But there's like lots of different ways you can use this information. It's not hard, it's just different, okay, than what we're used to. Yes.
Is there any way we can use this like how we did yesterday with the finding the area under the curve with the rectangles? Can we kind of use this, because it seems like
No, that's a different thing. This can be a different thing.
okay,
Yeah.
but if it was a bell curve, we could find the area.
Mm,
Never mind.
No,
It'd be
yeah, it's
basically-
gonna be different. It's
Okay.
different than what you're thinking.
I see.
This is more statistics related.
Okay.
So you use this when you're doing statistics. And I'll show you some examples using statistics. Yeah.
Well, I'm glad we're learning this because like 5 of my stage math test questions were on this and I was like, I had no idea what it was
Yeah.
talking
Yeah.
about.
And when I do the formative where we're gonna practice, I'm gonna practice a lot of these too, because I don't think we practice enough in here. It's super easy, it just seems, because it's different, it seems like it's hard. So if we have mu is 28.2, now this is an example, talks about gigawatts, there's a laser beam power, it's normally distributed with a mean of 28.2 gigawatts and a standard deviation of 0.7 gigawatts. We write standard deviation using the, isn't that sigma?
Yeah.
Yeah, the sigma sign. And so in our example, it said, so as you read it, it'll say it's normally distributed with a mean and a standard deviation. So the questions are like, what percent of the power is between 26.8 gigawatts and 29.6 gigawatts? So what you do is you figure out how many standard deviations is it away from the mean. So what I would do is I would take 28.2 and subtract 26.8 and I get 1.4. And then if I did 29.6 minus 28.2, I get 1.4. Every 0.7 is a standard deviation. So this is 2 standard deviations from the mean, above and below. So the percentage is this 95%. So 95% would be that answer. What if it was between 27.5 and 28.9 gigawatts? Again, we would subtract from the mean or from this one, the mean from that one. So 28.2 minus 27.5 gives you 0.7, and 28.9 minus 28.2 gives you 0.7. So this is exactly 1 standard deviation on each side of the mean. So if you were to go 1 standard deviation on each side, that's 68% of it. And then I have another one that says, shoot, I want to turn the page, but then I won't be able to look at my notes. I'll have to go back and forth. So between 28.9 and 29.6, if you notice, these are both above the mean. So it's not going to be, this way. So 28.9 was 1 standard deviation. We found that out before. And 29.6 was 2 above the mean. So we want to know what percent is between these two right here. So it's going to be half of, no, we want this one right there, right? Between 1 and 2 above. So not the whole thing, but 1 and 2. So we want to cut 95 in half, and then we want to cut it in half again. of 95. Yeah. So we'll do 95% divided by 4. 23 3/4%. That's not what they have. Hang on a second. Oh, whoops. That's not what we do. Dang it, because they're not exactly in half. Gah! Scratch that out. That is so bad. Okay. You have to go, yeah, you have to do, because it was 68, 95, 99.7 rule. Okay, so between the, what's that called, the mean and the one standard deviation is 34%. Sorry, so half of this is 34%. Half of 95 was 47.5. Yeah. Now you subtract those two. Sorry, you want to subtract 47.5 and 34. So it's not exactly halfway. So the way this is drawn, this is not exactly halfway between those two. So it would be 13.5%, and that's the correct way to do it. So we took our standard deviation. We had 34% was right here, and 47.5% was between the mean and second deviation. Then you subtract the two to find out how much is between there. Okay, yes, McKenna.
You did the same thing if you do 95 minus 68.
Yes, you could do that. Okay, good. I like that. So 95 minus 68 and then divide by 2. Okay, and then if we want to know what percent is over 30.3 gigawatts. So we take 30.3, we subtract the mean, that was 28.2. 2.1. That's 3 standard deviations. So if you remember, 99.7 is between 3 and 3. So we want just this part. So if you take 0.3%, that gives both of these. So you have to do half of 0.3%. So these two together is 0.3%. So we take half of that. And 0.15% would be above 30.3. Because 99.7% is here, so 0.3 is there, and we only want above, so it's half of it. Yeah.
So
Spencer.
are the shade, the part you shaded, the outside regions, are those theoretically go on forever, I guess? Because you could have like a so far one way outlier way far away, or is there a certain place where it ends?
No, theoretically it continues on,
Okay.
but you can't really, because of 0.3, you know, there's a specific amount that's
Yeah.
0.3% of the data value. So
It's irrational, it's not exactly 0.3, right?
no, it's 0.3%.
It is.
It's found out in these outer areas.
But is it exactly 0.3?
So it's,
I have to explain how to standardize a normal distribution. So this is like when you get your tests back and they say that your scores are, you know, they give you a certain score. It's been standardized against everyone else that took it so that they have a mean value, like right in the center, to make it a standard, a normal distribution. So that's what we're going over next real quick here. To standardize a normal distribution. So you take, this is called the Z-score. We just call it a Z-score. You take the value and you subtract the mean and then divide by the standard deviation. If you get a negative number, then you're below the standard mean. If you get a positive number, then you fell above the mean. So I want to do an example. And this is the example. This is super cool because you could use this in real life. So here's a person was offered a job in Bismarck, North Dakota for $34,500. Okay, so in Bismarck, $34,500. And then they got a job offer in Anchorage, Alaska, paying $51,500. And we want to know, which one would you take? Now, you don't look at the actual salaries. What you do is you look at the mean income. So the mean income in Bismarck is about $32,000 with a standard deviation of $4,500. Whoops, 2 zeros. Okay. In Anchorage, the mean income is $48,000 with a standard deviation of $7,000. So what we want to do is we want to find a z-score. We want to standardize each one and see which one is closer to the mean or above the mean, further above, I guess. So you're going to get paid more. You want to go where you get paid more than compared to everyone else, okay? Because there's a cost of living and everything. So to do that, you take the x value, which is 34,500, subtract the mean, 32,000, and divide by standard deviation. Then you do the same thing in Anchorage and divide by 7,000. So here you get 0.56. So it's above the mean by 0.56. Here you get 5 above the mean. 0.5. This one's greater, so it would be better to take the Bismarck job. Alaska can be a nice place. I like it. Okay, so that's standard deviation. I'm going to end the tape.